Good morning, all. So, today we are having the joint seminar by Dalhousie University and SRM University on the topic of the future of farming, digital transformation in agriculture, livestock, and aquaculture. So, I welcome you all for this joint seminar by Dalhousie University, Canada, and SRM IST. The presenters are Harini Shree Bhaskaran on advancing livestock health management, building a cloud-based IoT systems with AWS and Python from Dalhousie University, and followed by Umang Mehta on artificial intelligence and satellite-based GHG benchmarking for Canadian poultry farms from Dalhousie University.
Ma'am, your mic
Yes.
is mute, ma'am. Mic is on mute. We couldn't hear you.
Oh.
Mic on.
Okay. Now, ma'am?
Now okay.
Thank you, ma'am. Thank you. Good morning, all. So I welcome you all for the joint seminar on the future of farming, digital transformation on agriculture, livestock, and aquaculture by Dalhousie University, Canada, jointly with SRM University, Chennai, India. So the today's presenters are Harini Shree, Umang Mehta, Dr. Kode. So first two are from Dalhousie University. Next, after a small break, Dr. Kode from SRM IST Agricultural Department, and then Dr. Tamilannal and Shreya from SRM IST Agriculture Department. Then Professor Suresh Neethirajan from Dalhousie University. Then Dr. Sindhuja from SRM IST, and then Dr. Nagamalleshwari and Usha Suganya from SRM IST, followed by Dr. Vaishnavi from SRM IST. So finally, we are planning for panel discussion and closing ceremony from 3:30 to 4 o'clock. So I request everyone to join here and mute yourself, listen the sessions. This will be more useful for the research scholars, those who are working with computer science along with agriculture and aquaculture and livestock. So welcome you all once again. Now I request Harini to initiate her presentation.
Is my screen visible? Hi, good morning. Is my screen visible?
Yeah, it is.
Good morning to one and all gathered here. I take immense pleasure to thank my professor, Dr. Suresh Neethirajan, and SRM University for giving me this opportunity to present my thesis in front of a wonderful audience that is present today. My topic is on development of a cloud-based IoT system for livestock health monitoring using the Amazon Web Services and Python. So the Internet of Things has always changed the world with its immense diversities that can be applied to almost all the fields, starting from decades, it has been used widely across different disciplines, be it home automation from home spaces, smart electricity, smart cities, smart housings everywhere. Internet of Things has always been a vital part in almost all the fields. So here in today's presentation, let's focus on the involvement of Internet of Things in agriculture field. So we can see from this graph, it is evident that the world population, which has grown over this decade, and the number of connected devices has been in trillion. It is estimated by the International Data Center that by the year 2025, the number of IoT devices will generate a data of about 75.4 zettabytes, whereas the world population will still fall back by 40%. So this is the amount the Internet of Things has actually evolved in our lifestyles. So how this Internet of Things is going to impact the agriculture industry is that the immediate and instantaneous actions which can be taken in real-time aspects is become very useful, or it has become very handy when it comes to the usage of Internet of Things. So here I would dive deep into the livestock management aspect, where livestock management is one of the key factors which contributes to the economic growth of any country. So here in Canada, where the Canadian vineyards, the livestock we are considering here is a wide variety of cattle, be it sheep, be it pigs, chickens. A whole lot of livestock is still contributing to the economic growth of the country on the whole. So here in our use case, we have the enhanced animal welfare, prevention of loss and theft, optimizing the grazing management, tracking the farm products is one of the most important aspects of the Internet of Things in livestock management. So why do we use Internet of Things in livestock management? Is to early detection of the disease, improve the breeding capacity, increase the productivity, and optimize the milk production, real-time monitoring, and instantaneous actions. To emphasize on these aspects, so the early disease detection helps in prevention of the disease being spread to the overall herd population rather than being specific animal being treated. So this is an important aspect when the herd is in large number and each animal cannot be monitored individually. Next important aspect is the insemination and the rumination process. The improved breeding capacity has been more vital, choosing the best breeds of all. So the breeding process is also very important, and this Internet of Things has actually contributed in more improved breeding activity, increased productivity. So right when the animal is born till the delivery to the market, to increase its productivity and profitability, livestock management has become a very important aspect in the field of uh, the agriculture field. So here the Internet of Things again plays a very vital role to increase the productivity. Another important factor here is the optimized milk production. So the milk production is again being a very important aspect in this livestock farming. So having Internet of Things here will enhance the milk production, have the count of what the milk products that are being the different chemicals that is being generated in the livestock, and detect the health status, keep a watch on the milk products that is being delivered, and this actually meets the farm to fork aspect. A real-time monitoring will also help in disease detection. The other activities, if the animal is in a supine position, to overcome all these, the real-time monitoring is very important. Also, this caters to instantaneous actions where the animal is being responded very instantly and treatment is given at the instant instead of spreading the disease across the population. On this slide, I would like to explain the significance of the grazing management, where there is a farm. The farm consists of the different livestock present, and there is a bridge. So this bridge will be the Internet of Things and the Python application that I'll be proposing in the subsequent slides. which actually bridges between the gap between the technology and the traditional farm. So here in a traditional farm, all the benefits of all the livestock and the animals is being delivered to the customers directly when digitalization happens. Digitalization has overtaken on almost all the fields, and it has reduced more of the manual labor. It provides more profitability and economic productivity. Hence, involving Internet of Technology in this field is very critical in making the field more productive. So to consider about the traditional farming and the smart agriculture, the main aspect of here is in conventional farming, the working population ages, whereas in a smart agriculture, with the digitalization, with each technology coming up every single day, we will be experiencing more precise and accurate solution in comparison to the workforce in the traditional farming where the population ages in so after certain period. A novice farmer who is just joining the farming industry will have no much expertise, and this hinders or sets a fallback to the population being able to analyze the livestock, whereas the digitalization will certainly be improved over the decade and over the years. Next important aspect of Internet of Technology is the time consuming part. In a traditional farming, manual labor is involved, whereas in a smart agriculture, everything is automated. Manual check will also involve human errors, whereas in smart agriculture, all these human errors can be overlooked. On the production aspect, in a traditional farming, it is totally unpredictable unless and until there is a keen watch on how the livestock is working or how the livestock is, the movements or the body pattern is keenly observed. Whereas in a smart agriculture, this is efficiently handled with the use of sensors or wearable tags or the images data, which keeps updating in the architecture, and decisions are made very instantaneously so that real-time actions can be taken very quickly and more promptly. Another recent study shows that the global hunger, where the starvation did persist in the African countries due to the traditional farming methods, is being replaced now slowly with the emergence of smart agriculture. Hence, use of Internet of Technology in livestock will definitely be a prompt solution in the upcoming years. So here I would like to talk about my thesis proposal, which is the agile and scalable architecture. What agile and scalable architecture here I would suggest is an agile architecture is something which caters to changes, and scalable which is being scalable to different farm size. Building such a model would be a prompt solution where the size is not fixed and it can be used in different use cases. The second important aim of my research would be accommodating more than at least 200 IoT device sensor. With a growing number of IoT sensors, it is very important to accommodate all those devices, and these exploding numbers should be kept in consideration when it comes to building a real-time architecture. Also, building a single framework to multiple farm size would be a much easier solution when it compares to the cost aspect of this problem. Making a stoned framework which needs investing in a lot of capital is a prodigal idea. Hence, building a framework that can be used as in different use cases will be the right solution. So I would like to briefly explain the methodology that I'll be using. So the data from the livestock, from the barnyard, it has the IoT devices being connected to it. So a variety of sensors, including a thermistor, ultrasonic sensor, accelerometer, and heart rate sensor. So different kinds of sensor is being incorporated on the livestock from where the data is being collected. And with the help of the Internet of Technology, it is being transferred to a cloud platform. Here, I will be considering Amazon Web Services as my cloud platform where the data is being stored. So once the data is collected from these sensors, the data is then sent over the internet through an edge computing device, and then the data is sent through a cloud. And after the data is being processed over the cloud, the final output or the final solution is being sent to the end user, which can be the farmers, the veterinary doctors, or the government officials. So here what exactly happens is on the edge computing device, the monitoring part happens and the data is being stored locally. The locally stored data is then sent to the cloud platform where the data is being monitored, analyzed, and evaluated for efficient solutions and an easy way of interpreting, such as an SMS notification, is being sent to the end user. This not only makes easy for the end user, but also a real-time aspect of instantaneous solutions can be given simultaneously and synchronously. Prerequisites of designing an IoT model involves the model to be a robust model, it should be a scalable model, it should be affordable and sustainable. Considering these four aspects, I have proposed this model in such a way that it pertains to all the prerequisites and be accessible to all the population, even including the remote areas. So in my use case, I have considered a data set where the data is collected from a tripartite sensor considering 5 pigs, which is aged between 86 to 108 days, and the different parameters that is being accessed from these pigs include their heart rate, the accelerometer rate, the breath rate, etc. Now, I would like to talk about the technical part of my project, which includes the edge computing. So we all are aware of the cloud computing, but what the edge computing means. So edge computing, as the name says, it works on the edge. That is, it is decoupled from the actual entire architecture of the cloud. And on the edge side, the basic or the instant reactions that has to be taken, the data is being stored here rather than to getting the data directly from the cloud, which involves a lot of time. This edge computing also ensures decoupling of IoT devices, which ensures the scalability. So any number of devices, say from 5,000 to 2,000, can be upscaled or downscaled depending upon the farm size, depending on the use case, it can be decoupled. So the scalability part of the architecture totally relies on the edge computing. The agile method is being used here so that the changes can be made, collaboration and flexibility of the model can be done very instantaneously in a real-time situation where model should be very flexible and be adaptable to different scenarios, and agile methodology becomes an important part in building an architecture of the livestock health monitoring. So agile here in simple terms just means changes. The changes in the market, changes in the requirement, changes in planning, changes in design, they usually caters to this agile methodology. So here, agile methodology will be considering the use of the market knowledge, the virtual corporation approach, time compression, rapid configuration, and robustness. All these are ensured and the model is built based on the principles of agile methodology. In previous works, as discussed, people have used the AWS IoT Greengrass core as a part of building a scalable and flexible cloud architecture for the livestock health monitoring. Some of the drawbacks include the scalability aspect where when more number of IoT devices have to be added or removed becomes hindrance when you build the IoT, when the architecture is built using the IoT green grass. Hence, to overcome this hindrance in my model, I shall be using a framework called as NB-IoT, where this protocol works on a low-range platform, but also ensures more number of IoT devices being connected. As a demo model, here I have simplified the overall architecture by using the Amazon S3, AWS SageMaker for machine learning analysis, AWS Glue Data Brew for the predictive analysis, and QuickSize to build my dashboard. So this is a very simplified model, which includes the data set of the 5 pigs that I previously mentioned to show how the overall architecture works. As mentioned, this is the NB-IoT, that is the narrowband IoT, which helps internet connectivity reach the places where in remote areas where internet will be thought impossible to reach. Hence, this will also reach any number of farmers in any rural areas, a remote place where internet is still a question mark. So here I have shown the dashboard of my health monitoring system, where it is easily understandable from the dashboard to the farmers or the government officials